Moving on to example 3. We are told IF is perpendicular to HG and IH is congruent to IG. So I'm going to mark these two sides. And then I'm going to look at this given. Okay? As you recall, perpendicular lines lead to right angles, which can lead to right triangles. So we have the possibility of hypotenuse leg, but we can also have the possibility of angle, angle, side, side, angle, side, and angle, side, angle. The key here is when you want to use hypotenuse leg, look to see if you have information on the hypotenuse. Okay? If IF is perpendicular to HG, then we have right angles, right triangles, and notice that we do have information on the hypotenuse of both of these triangles. So this is the direction we're going to go. IG and IH are the hypotenuse, or hypotenuses. I don't know the plural. We're going to go with that. Okay? So now we need to fill in our proof. Start with our given. IF is perpendicular to HJ, and IH is congruent to IG. Given. Okay? Now, remember with perpendicular lines, we have to follow this process. We need to establish right angles to establish right triangles. So that's where I'm going to begin. And I'm going, because these angles are numbered, that makes it a little bit easier in the proof. Angle 3 and angle 4 are right angles. This is because of the definition of perpendicular. Perpendicular lines form right angles. That means triangle HFI and triangle GFI are right triangles based off the definition of right triangles. Okay, so I have my hypotenuse. I need to find a leg. And notice again, we have a shared side, which so happens to be a leg on each of the triangles. So IF is congruent to IF, reflexive property. So our triangles, HFI and GFI, are congruent due to hypotenuse leg. Okay, one thing I want to point out, in this statement here, you could have also had angle IFH and angle IFG are right angles. I chose to take advantage of the fact that these are numbered. Okay. All right, moving on to example 4. We have a lot of given. ML is congruent to OP. We've got that marked. NL is congruent to NP. That's marked. And N is the midpoint. Again, midpoint splits the segment into two congruent parts. So essentially, this midpoint allows us to say that MN is congruent to NO. Okay. I look at my diagram and I have side, 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 side. All right? So we start with our given, ML congruent to OP, NL congruent to NP, and N is the midpoint of MO. That's all given. Then we can say that segment MN is congruent to segment ON. Definition of midpoint. Therefore, triangle LMN is congruent to triangle PON due to side, side, side.